Hello, everyone. Welcome to this webinar. I'm Robert Pack. I'm with Databricks, and we're here today with Scott Haines, a distinguished engineer at Nike. Previously, Scott and some friends from the community talked about clustering, and it seems like there are some unanswered questions in that field and some nice follow-up stories to talk about. And today, we'll be diving deeper into some interesting patterns, some interesting stuff you can do with clustering, especially combining traditional hive-style and liquid clustering patterns.
Yes.
Yeah. Welcome, Scott.
Thank you, Robert. Yeah, so this for people who joined before, we had the Beyond Partitioning webinar back on the 14th of February. And as Robert was saying as well, the questions that came in afterwards were more on what if we need to use both? Or what if liquid clustering doesn't work for our use case because we're changing partitions in our table, we're overwriting complete partitions. A lot of the table is being overwritten more often than not. So this webinar is essentially an answer to how to use both. And we can kick off right about now. All right, we just need to, Carly, can we advance to the first slide? Awesome, cool. All right, so everybody else, we're gonna get to the slide that we just saw. But first, we're just gonna kind of walk through a little bit of a background on Beyond Partitioning. And then we can walk from there as well. So essentially, this whole entire talk is called The Best of Both Worlds, because then pretty much any kind of data engineering use case, decisions matter, and the way that the table performs is very much dependent on what it is that you're trying to do with that given table. And certain patterns aren't going to work for liquid clustering. Certain patterns are going to work better for traditional hive-style partitioning with z-order optimization, or with just typical bin packing optimization for just faster, more consolidated data within our partitions. All right. Let's see, advancing slides. Let's see if I can advance the slides. Okay, perfect. All right, so for people who didn't join the other earlier session, Beyond Partitioning, there's the bit.ly. You can capture it with your cell phone, do whatever else, or there's a YouTube. Just you could search it in YouTube and find it as well. So that goes into a lot more of the details about what we're going to kind of glance over today on the key differences between the way that our table is laid out with hive-style partitioning versus the way that the table looks when we're actually using liquid clustering. And the semantics of both differ. And so we're going to do a quick recap right now as well. All right. So if we think about optimization techniques, right? This is essentially the foundation for the decisions that we need to make as data engineers, or even as data architects, thinking about things as a contiguous flow, from the point of data inception all the way to the point of egress into a specific system and or for a specific use case. So you think about traditional BI, AI, et cetera. How do we use our data? But when we're thinking about what we do with the data when we receive it and when we process it, a lot of times we go back to kind of first principles of write semantics or read semantics. So it's really, what are we trying to optimize for? For write, we want to ensure that we can insert data quickly, right? And in a lot of cases, we're not going to be inserting row by row by row by row by row by row by row. We're going to do that in a batch, whether we're going to buffer a certain amount of data, and then we're going to do that insertion. In a lot of cases, if you think about why liquid clustering works well, liquid clustering works really well in the case where you're treating a table as almost append only. So it's we have sealed kind of finalized data, and that is being added to the table, but we're not really doing any kind of delete operations at a point delete. So we're not looking at specific records within specific partitions. We might just be chopping the end of the table off at a specific cadence for GDPR for any other reasons. And then we also think about specific caches or anything else like that. So can we share caches when we're doing writes, if we're writing to multiple tables, anything else like that? There's a lot of different tips and tricks that can be achieved. On the other side, we think about how do we optimize for read, right? I want to optimize with highly compressed, limited number of files, so that any operation that I do to query is literally looks at the smallest number of files. So we were taking a look at like the, any of like the actual, like, the performance of like a specific SQL query. A lot of time you're looking at, how do I reduce the time from query to the point of answer as well? And so any traditional data system, we think about write optimizations and read optimizations. This kind of takes us into, the table decision indecision type problem. So what do we do, right? We have hive-style partitioning, and while the whole entire talk is called hybrid clustering, like we think about things in terms of essentially like what's the layout look like, and then how can that create clusters to be able to enhance our ability to query. Like I want my query to be as effective as possible to reduce the time from question to answer. So with hive-style partitioning, where it shines really is providing like read and write isolation against very specific paths within the underlying table. So if I think about looking, for a specific date by a specific, other, partition column, like in the example we're gonna look at later, it's like, it's a distribution center ID. It's like super fun. But it could be, essentially anything, right? But it really kind of matters for like the queries that I'm trying to speed up. And with hive-style partitioning, you kind of make the decision once. That's encoded into your table, and if you want to go change, you have to overwrite the entire table. So it works really well where it works, but it's not as flexible as like liquid clustering. Hive-style is also really good for data skipping because you can essentially ignore all the paths that don't fit the happy path to the data that you need to get to, which makes it a lot easier to then query as well. And like, if you just take a look at the underlying data, it's fairly easy to understand how the table looks. And that's also where like, the ability to, automatically scan and find partitions, is pretty cool, like on the Hive side. With liquid clustering, you have, yeah.
So for interjecting, just one thing, I also find that hive-style partitioning, while not necessarily the best for query optimization, when you want to share your data across the organization, and then maybe use delta shares on individual partitions whenever you need this sort of sharp boundary. It's a bit beyond sort of what we're talking about today, but yeah, if you prepare your table to be consumed by externals and you need a very sharp boundary across the data, I think that's something where hive-style partitioning also definitely still has its place.
Oh, for sure. And I agree with that as well. Given that you have, like, at least like with the delta shares, you're usually doing that by that partition anyways. And that's easier than having to go and create like an isolated view to then share as well, which is nice. So for the liquid clustering side, as the recap there as well, like we remove data skew because we no longer have the notion of like partition boundaries. And so if we don't have the notion of partition boundaries, then we can optimize the way that the files are laid out, because we don't have to worry about like, that edge that we're just talking about with that crisp edge. So it's no longer like the date and then a specific, subdirectory within the table. We can now kind of efficiently create, fuller files that reduce our data skew. So we eliminate the small file problem as well. And then liquid clustering also supports like incremental optimizations as you go. And the reason why like that's being brought up right now is that if you are overwriting a large portion of your table, incremental optimization no longer is something that's very effective, because you still have to go back and continuously re-optimize the table because you don't know where in the table you have been doing your overrides. So it can be a little bit more complicated. And so that's kind of where like the beginning of this whole entire conversation starts, where if we want to use both, then how do we do that? And, that ends up basically being like our initial question. So if you think about this as like a Goldilocks style problem, choose whatever oatmeal you want, right? Hive-style partitioning, let's talk about that as like too cold, maybe. And then liquid clustering, let's say that that's too warm. We want to find like a happy medium. We want to use both, but we want to use both where it actually makes sense too as well.
And maybe just for context for everybody listening, so the file size matters a lot, right? Because one thing that's highly optimized these days is Parquet reads. So you really want to end up in that Goldilocks zone, because there is a price to be paid per every request you do. So you want your requests to return enough data. Yeah, so this is very, very important optimizations for your table to have sort of just the right file size.
Yes. Yeah.
And with files also meaningfully bundled up, chunked together, right? So that
Yeah.
that yeah.
Yeah, I mean, it's the analogy. I don't know if anybody understand. Like, we don't really defrag anymore, right? But it's like whenever your computer used to be really, really slow back in the day, you defrag, and then everything would be optimized again. And that's really the same thing that we want to do here, as well as create an optimal, like, well-oiled machine.
Yeah. If you wanted
Hence
to spend a couple
optimized.
of hours looking at little blocks move, right? Then
Yes, which is still super fun, right? And
yes.
I feel like that, like, behind the scenes, it's still really what we're doing, right? We're moving blocks of data around, and we're essentially ignoring and, like, removing the visibility of those older blocks as we've coalesce them into larger chunks of
Yeah.
contiguous memory. All right, so going back to Goldilocks, right? So what's our third option? We brought up the two. We have hive-style partitioning. We've got liquid clustering. We sort of already buried the lead before anyways, but, like, the third option is essentially just, why not use both? And you can't use both in the same table, like, and that's there for a reason. And so a lot of, like, the ability of using both goes back to essentially more of, like, kind of like the medallion architecture. So there's going to be specific phases of execution where you're going to use hive-style partitioning, and then at certain points in time, it makes a lot more sense to use liquid clustering. And there's some interesting things we can do with virtual tables that we'll get into as well towards the end of the presentation, that shows kind of how do you get the best of both worlds from both hive-style partitioning and then liquid clustering. I wish it was just clustering, but we'll move on from there. Semantics. All right. So for the use case, let's go back and forth with this. Talking to Robert over the weekend, and it's like, I come from a shoe company. I come from Nike, and we have, like, distribution centers. We've got fulfillment centers. We've got all these things that would require maybe the entire presentation to talk about for so that we all had the same sort of understanding of the way that things flow from the point of somebody ordering something to the time that something shows up on someone's front door, like logistics and supply chain and everything else in between. I removed a lot of those slides because it became too much, and so in this case, the use cases are going to be a little bit more generic, but talking more about, like, kind of fast and slow systems. And then for people who haven't heard of, like, close of books, I'll just talk about close of books right now. And close of books are technically, it's a window of time in which a table is mutable. Like, I can make as many changes as I want, wherever I want. And when the close of books interval closes, at that point, I can consider my table stable. So essentially, we're looking at essentially, like, short-term and long-term memory. If we want to think about, the system in that case, like, how do we modify things so that we can, handle a specific use case in the short term? And then once everything becomes more stable, then we can go back and fall into, like, more of, like, the liquid clustering type use case. So what does that workflow look like? So before, we took a look at essentially newest to oldest, as things are kind of moving from, like, ingestion back in time. And then in this case, this is more of, like, how you would look at the system as data is flowing through the system. And so time is basically the variable that we care about the most here. So we have source data streaming in to a table. We've got multiple sources. Those sources could be keyed on a specific, like, identifier. It could be coming in from different Kafka topics. It could be coming in from different, operational data stores. That part doesn't matter as much for, like, the entire conversation. Just knowing that there's multiple sources getting into a table. So in this case, the table is called lifecycle events. We don't have to really worry too much about it. There's, like, code that we're going to go through afterwards, but in general, like, lifecycle events are essentially just stateful events that talk about, state changes. That's pretty much it. So in a lot of cases where you have, like, let's call it an unstable period for a specific table, you might be doing complete partition overwrites. There might be laggard data coming in, 2, 3, 4 days late. And there's different ways of kind of working on that type of, like, highly unstable table. And a lot of times, like, you think about that as, like, close of books, right? We've got a certain amount of time in which we can fix our table and we can make it perfect before we actually end up using, before we end up allowing that to be, like, more of, like, our kind of, like, long-term memory. So in the short term, who cares as much? Long term, let's make sure that everything is completely stable. And so as all this stuff essentially starts to age out into that close of books, like the end of the close of books window, we basically just let it fall back off onto like a more stable table. So kind of top left, where we think about supporting partition overwrites and upserts, we think more about using like hive-style partitioning, because it gives us that like write isolation. Like I can go and update a very specific path to a specific, distribution center, for example. And so those subpaths can be overwritten without affecting anything else within the table, without affecting essentially any other, underlying Parquet files. So I never have to think about, muddying the waters with stuff that might already be a little bit more stable. Robert, did you want to say something?
Yeah, no, I just wanted to motivate this a little bit more as well, right? So I always, in my previous life, also worked in a process company, and I always envied, I don't know what the right term is, the digital native companies, right? Where your event logs, your click streams, whatever. I'm not saying this is an easy data problem, but ultimately the data is fairly correct kind of when it gets generated. But as you move into the physical world, as you move into the field, right, life gets really, really dirty. And this is why I mean, not only late arrivals, right, erroneous data all over the place. So there needs to be some frequent updates if you don't want to sort of just swamp up your historical data store, right? And sometimes these windows needs to be fairly long. But this may be, because if you're just talking about logs and state machines, right, you could just say, okay, I mean, just do a new state, do an update, I don't know, new style. Why overwrite stuff, right?
Yes. Yeah, I think that's all. I mean, that's also like a really good, I tend to like to live in that world where, we have correct data flowing through the system. That makes me happy. The other stuff is a lot more of like, it's more of like the chores, but it's those chores that like encapsulate probably like, 60% of most kind of enterprise style like workflows. If you have, both that split of, real world and digital world, not just virtual goods, for example. Yes. Okay. So moving on from there, right? We have a table. In this case, like the retention is like 14 days. If we have a close of books interval that's 7 days, we're allowing more time for like very late arriving data, but it's only up to, a second entire cycle if we needed to go and move anything else out. And we're still essentially kind of popping off the data from like the shorter retention table. So going back to short-term memory versus long-term memory, as everything essentially becomes more stable, it flows into like a historic table. And then we can move on from there as well. So that's essentially the gist of this entire design. And now we're going to work through essentially like, how do we get that best of both worlds? And so if we think about this as essentially like a series of operations, a series of steps within a workflow, in a lot of cases, you think also about Medallion as being like a series of, plays and maneuvers through, kind of a well-orchestrated, series of layers for your data. And so if we think about this type of problem where we have, close of books, and then we have, data that is now in long-term memory, and then we also have, potentially what's our current active view look like? Even though it's changing, it's still stable between changes as well. And so we want to be able to take advantage of, reading from that unstable memory while also mixing it with our, actual stable memory. And to do that, we can use virtual tables. So a view is a virtual table. So it's, a representation of a physical table, or, multiple physical tables as well. So in this case, it's essentially a union of our historic table where our data has landed. And our historic table is all done with liquid clustering, while our current table and the view of the table, which we'll take a look at in just a second, is essentially that 7-day period in which, we're currently looking, which is that active close of books, period. So this is what we're going to build. And so I'm talking about this as a kind of a mixed optimization technique. It's not perfect. There are many different ways of doing exactly the same thing. But this is one of the easier ways of being able to handle a complex use case without getting into, structured streaming and hanging on to, 7 days, then watermarking and doing anything else like that. That's more challenging. This way we can just use Delta all the way. And so it allows us to do, to kind of mix and match the ways of working as well. All right, so foundational ingestion table. So going back to kind of, the design we had where our data is coming in, it's being periodically updated, and then it's falling off into our historic table. We have this foundational ingestion table. So the requirements are essentially the write isolation. We want to be able to support, like, easily support multiple writers, and having those writers essentially write into very specific, paths within our underlying table. Sometimes you'll have, all of your streaming data coming in certain places. Then you'll have essentially like, a job that might be packaging, like last day of data from, local internal on-prem, warehouse, for example, that's then being pushed into like the cloud, like on a specific cadence. So kind of that merger of real world and, what's up in the cloud as well.
And this would be sort of the one of the motivating examples, right? So you have many distribution centers, many local warehouses. Each of them are guaranteed to write to exactly one par segment, so they're guaranteed to never contend with one another. So you make conflict resolution, all of this kind of stuff, much easier for the Delta protocol.
Yes. Yeah. Not having to worry about So any concurrent modification exceptions, trying to not ever worry about that as well, which is just wonderful. Yeah. Then let's see. So for requirements as well, like there's possibility of doing merge operations as well, because we want to be able to make changes to individual records that might have, early on had most of the information we needed. And then, we talked about, kind of dirty data, right? And so sometimes you have, it's like an inkling of what the event should be or what the row of data should be. And then it actually gets better and then it needs to be updated. And so being able to support like upserts and everything else, like during that, period of instability, it's the right way to say it, is always like something nice to have as well. So so also this enables like very simple delete boundaries, like for our partitions, like as we want to age this table out, if we want to think about that retention of the 14 days, it's very easy to do a conditional delete, basically chop off like, the end of our, retention window, just let that fall off on the other side. So kind of the reverse of what's going on as our data is flowing through and we're moving it to historical. On the end, we're basically just chopping off, the 15th day as we're rolling over. And then that becomes kind of this, it's an bounded machine right at that point. So over here, we have our table. So basically just to give, a little bit more kind of idea of like what it is we'll be, kind of showcasing as well. But it's like, we've got event time, we've got an event date. Event date, we're just generating from the time itself. This is being done more specifically for our partition by, because we can't partition by high cardinality information. We really wouldn't want to either, because if we had like milliseconds, we'd be creating, many directories. We'd have a very terrible table layout. We've got event types. We talked about distribution centers with DCID. There's products that are being they're flowing through a distribution center, and there's like units. So it's a number of, product available for some specific, type of event, whether like we've received, a new batch of, million shoes, whatever else. And so this is a very simplified view of like what this information would be. So we create a table, we're partitioning by event date in our DCID, kind of going back to that isolation that we want for that write isolation. And then also we have something, it's just it's the data skipping stats columns. So for people who are used to just like the not being able to select, it's like what's the other property? It's the data skipping num index columns. Yes. So before you used to say, okay, like we're going to automatically index like the first 32, 32 columns, and that's going to be essentially kind of like, depth first across our individual table. In this case, you can specify very specific columns that you want to index instead. So we're ignoring like our timestamp, so we don't have to reorder like the table, and we're just pulling out that event date. Sorry, I got very excited, hit my keyboard. We're pulling out event date and then like the product ID as well, because that's better for, our ability to make, certain queries work while we still have this partitioned, classically partitioned table.
And just as an FYI, so in this case where we only have very few columns, you could probably just go ahead and collect stats on all of them.
That's true.
But collecting stats also can be something important, something to be reasoned about. Yeah. If you have a lot of nulls in there, your stats become, I don't want to say meaningless, but less helpful.
Yeah.
stuff like this. So it's definitely something to reason about. But this is also why liquid clustering exists, right? Because it's a non-trivial problem to reason about clustering on complex scenarios.
Oh, for sure as well. And like I think so for this one, thank you for bringing that up, Robert, as well. Because like if I think about like the schema of like what this table would actually look like, you know, there's probably about 150 different kind of columns per row within this as well. And so this is kind of like here's a sample of like, the very minimum amount of information that's needed as well. But yeah, in this case, right,
yes.
Literally query, like that's fine. Index everything. Very good point. Less things to think about as well over there. All right, so we have our ingestion table. And now if we think going back to, how do we deal with like our short-term memory? And this is the period of like our close of books. One of the interesting things that we can do to help simplify our life is essentially to create functions. So functions can be used to make your query simple, whether it's a Python UDF, whether or not it's like registered function in Unity catalog that allows you to go and say, okay, I'm going to go and create like close a book date. What does that function look like? I'd like to be able to go say get close of books. Awesome. That's going to return a date. That's great. And now I can use that to essentially chop off on either side of like my either side of the table so that I can do interesting filtering functions. So for people who haven't created the functions before, on the right-hand side of the screen right now that you're looking at, we're creating or replacing a function. In this case, it's bound to like a prod catalog in Unity catalog. We're calling it data center ops, and then I'm saying get close of books for a specific number of days. It's returning a date. The language is SQL. Awesome. So cob interval is close of books, not corn on the cob. But either way, it's fine, right? So today minus our cob interval is our, cob interval, whatever, is our close of books. And we're just using like simple functions, right? Current date is today. We're making an interval. In this case, that's going to pull in like our functional variable, right? Our days, great. So in this case, I can make unlimited close of books depending on like what actually needs to be done for specific, tables. And then this function can be reused across the board as well for other use cases. So easy to share. It's registered. Everyone's doing everything the same way, which is always good. So you don't have to worry about like data problems with functions and function reuse. And the other cool thing too is that like, so whether we're using real row filters, or if we're using, kind of point in time row filters like within like our views. I keep on saying row filters because at the very end, we're going to showcase how to do the row filters if you're using Unity catalog in Databricks. But outside of that, we can still use our functions, and we can still, use our function essentially to do like a conditional clauses, right? So in this case, like I have like, within a cob window, I haven't gotten to that part yet. I skipped ahead. So this new function is just reusing our other function. So you can reuse functions within functions for any registered functions. It's a lot of words, functions at the same time, but like I can, in the same way that I would create, reusable libraries, you can do the same thing with registered functions as well. So if I have something where it's a simple get close of books, that's awesome. If I want to bind a specific date, so say it's like, close of books, weeks, whatever else like that, those things could all be done and now also registered because it's something kind of normal, right? It's something that could be reused across the board. In this case, it's like within the close of books window with an event date. So going back real quick to just like row filters in general, like a row filter requires you to be able to apply a function that returns a Boolean for each individual row using data from within that row. So if I wanted to do like close of books 7 days or 14 days or something else like that, and use a row like filter function in Unity catalog, I would also need to have that information on every row. So that's not necessarily something that you'd want to do. So that's why in this case with what I'm showing get close of book 7 because I'm just basically binding this automatically so that the event date can be pulled on a row to row basis so that those partitions, basically so that every individual row of data can be filtered out based on this, predicate function. So,
and just for context for everyone, right? So, the problem we're trying to solve here is we have those two tables, but they have overlap in data, right? So we can't just union those tables and be blind about it.
Yep.
But as our data processing goes on, we need to hide sort
Yes.
of portions of that table. Otherwise, we get something that is inconsistent, something that would return erroneous data ultimately, right? So, and what you're explaining to us right now is, okay, how do we model these bins in terms of, and you mentioned it before, right? Row filter just says, because we need to slice off rows in a table. It's not necessarily a row filter in the UC sense,
Yes.
but yes.
Yes. Yeah. It's just trying to be able to clamp on like the boundaries as well. So if you think about like, you know, inclusive and exclusivity within what's current, what's active. We've got that 14 days. We only care about the 7 days. And then we also want to ensure that we don't have duplication within like our historic, table as well. So row filters are an interesting way of doing that. We'll go into more of the semantics with that in just a little bit too. So we talked about views before and leaning on like views and virtualization. So if I want to go and create like that clamped view that is giving us essentially that, those inclusive windows with exclusive boundaries, we can go and do that by creating a view that's selecting from our other views. And in this case, right, I'm creating like a current window. So creating and replacing my view for the current, I'm just saying _v, it's a view. You can also tell it's a view in Unity Catalog because it tells you the type also, but like depending on like the way that your company works, a lot of times people will just do like _v, whatever else to show that it's a view. So as select from our events, and in this case, we're just using like our function for the getting the close of books to say like, I'm just clamping this event date that's greater than like my close of books date so that I have that boundary. So moving on to historic table. So we have our current table. We know that data is flowing into that current table. The retention is 14 days. We care about the 7 days for close of books. And then as that close of books period ends, we just have a scheduled job that's running, like a daily cadence, to just basically pull off the last complete day, put it into historic long-term memory. So for this table, the historic table, we can use liquid clustering, which will help us to rapidly be able to go and read a longer historic window. So if you think about short-term memory being, essentially really only those 7 days, and then long-term memory essentially existing for as long as you need it, that's where this stuff gets kind of interesting, right? So liquid clustering is much better for stable data that's not changing as often. And if you think about this whole entire use case, our historic table is not changing very often. In fact, it's more immutable. And so you can really benefit from the way that liquid clustering works, so that your long-term lookups are fast, while the unstable data is also fast. And we'll take a look at that too when we take a look at the union of these tables and views. So,
and I don't know, just from my perspective, right? I think we not only have short-term, long-term, but let's say the domains are also switching.
Yes.
The short-term domains usually dominated by the needs from operations, day-to-day operations, trying to keep everything running, trying to keep everything smooth.
Yep.
Whereas historic data usually goes in the domain of business analysts, data scientists,
yes,
and all of this. So the query patterns also change, and as your business evolves, they also may change. Whereas your operational questions usually are fairly stable, at least in my experience.
Yes.
And that may not necessarily be true, right? But this also motivates why liquid clustering that is more adaptive, more dynamic, can sort of evolve over time as your business and your organization evolves.
Yep.
Yeah.
No, that's I think that's a really good point as well. Like, because you have the ability to do that also with liquid clustering, to go and change the clustering profile over time as well, without having to rewrite the entire table. And in a lot of cases, if you're rewriting like if I'm rewriting like a logistics or operations table for 7 years, I might have, a petabyte of data. I don't really want to go back and modify a petabyte just because I'm decided to make it, some slight changes or tweaks. So it's easier to then say, okay, we're going to change our liquid clustering like semantics, and then now incrementally our clustering has adapted from that point in time forward, which is always better. If you really have to go back in time to a certain point, then that's also life. So
yeah, it happens.
that works. Okay, let's see. So for this table, we talked about the cluster by. We have like our, again, we selected individual like data skipping like stats columns. We've enabled deletion vectors as well, because we're going to be deleting from this table as well as we go. And then also change like I did the deleted file retention interval for 2 weeks over here as well. It gives you some time to go back in time if you need to go and make another fix, anything else like that, before the underlying table disappears. So time travel is still in effect for that 2-week period. So if you think about the full retention of that current table was the 14 days or the 2 weeks, I want to be at least able to go back the 2 weeks if I have to triage anything from within that current period. But rerunning my liquid clustering over a 2-week period is much better than rerunning it over a 7-year period as well. So you can still make those changes. You can still go back in time. You can still replay, and it's as if you don't have to really worry about it as much. So Delta gives you those capabilities. So I've got my long-term memory, append flow. This is essentially just if you think about Kappa architecture, for people familiar with Kappa architecture, there's always, we've got streaming fast-term memory. That's great. It's moving as fast as it can. It's inaccurate, but that's okay. And then you have a slower system that's running that is much more accurate and kind of moving through the system as well. So if you think about this as close of books acting more of as the Kappa pattern, then this allows you to then, periodically, use streaming as batch over here as well. So in this case, we're reading our stream, and we only really care about pulling off the 1 day. But in certain cases, 1 day might be 1 trillion records. So you want to be able to still be able to, given that you're pumping out historic data, you don't necessarily need to have that, if it's running once a day, if it runs for 30 minutes, 40 minutes, it doesn't really matter. And you can still run it for cheap as well. So depending on, how you want to throttle, that migration from, current to long-term, that's fine. But you can do that, and ensure that everything's going to actually be written correctly with throttle capabilities as well. So we read our stream. That's awesome. We've got a starting and ending timestamp. That's creating that kind of clamped amount of time. We're pulling it from that lifecycle events table. Over here, I also have an additional filter. So if you think about the fact that we're pulling from starting timestamp or ending timestamp in Delta, all that Delta is going to do is it's going to read through the transaction log, and it's going to look for the closest version of the table to the starting timestamp or the closest version of the table to the ending timestamp. That might give you records across both sides of a boundary, and you don't want those duplicate records. So in this case, we're still doing a filter, but this allows us to essentially, get kind of, best of both worlds too, where we don't have to really think about it. We're saying, I know specifically where I want to go read from, and now I just want to filter, on those edges as well. And then this operation will run until there's no more data, and then life is good.
Just really quick, because we were mentioning filters again. There was a question kind of from out there, whether or not these table functions wouldn't be scalar. Yeah, I don't know. Is this something you want to answer, or should I answer this really quick?
So for this, so if you think about this, I can go back. There's 4 more slides. So if you think about the Boolean itself, right? We have what we're pulling out from the first function, where we'd say get close of books. Get close of books is returning a scalar date. So it's a singular value. Then from there, you're just using that to do your comparison operations. So where we have that first function, that is returning that one value. You can return anything else you want as well with any of these functions. But if you want to use these functions, to be able to do simple comparisons as well, all you're doing is kind of hiding the inner selects. It makes your queries easier. So
exactly, and just sort of in terms of scalar versus tables and stuff we're not hindering any execution optimizations, right? It can still be fully vectorized, still operate fully on columnar, but yeah, it's a row by row sort of evaluation that needs to happen.
Yes. Yeah, and I think that's the other thing we can get into as well when I have it's the one more thing. I think it's 2 slides from now as well, and then we can go deeper into the questions too. It's that more of that question of if you are doing row filtering, the row filtering is going to be applied dynamically, so you don't get as much of that cache stability as you would if you're doing essentially if I'm pushing down if I'm doing predicate push down on a partition, then that allows me to optimize the way that I'm reading at a partition boundary, which is better for that hive-style partitioning as well. And so let's go into that. We can go through the details of that in a little bit more as well. But I just want to talk about basically, if we really want to do inclusive and exclusive boundaries, and we also want to ensure that we're not getting duplicates, this is one of the simplest ways to do that with starting and ending timestamps and a filter. and then trigger available now. True. So best of both worlds is essentially creating that view composition. So we can union essentially the historic and current table of views. So in this case, if we had like lifecycle events underscore v, and then we're selecting from our, lifecycle events current v that we were showing like before, like that was using like that, essentially that predicate condition, like in our where clause, then unioning that with our historic view, that's great. We still get all the push down and everything else like that from like the Delta side, whether you're using like whether you're using like Spark as the execution engine, whether you're using like, Photon and DB SQL, you're still going to get the benefits of Delta understanding what it needs to read and what it doesn't need to read. So you're still pruning everything, which is also nice. So views are your friend. And so lastly, when we were talking about like the Unity catalog row filters, I just have an example from the other day of like the row filters with this actually running as well. The interesting thing, and I guess this is like, Robert, I don't know if you want to talk about like when not to use like secure views, but if you want to pick that one up, that's fine too.
Absolutely, certainly we can talk about this. So you showed how to do this with views, right? You can define classical views. Well, not classical views, just views that evaluate this query at runtime. You can, I'm not saying you should, but you can also define this as a policy on the table, right? So let's assume you're in some sort of, let's say, very strict requirement where this must never be wrong, right? Where seeing erroneous data may have implications that go beyond, I don't know, my dashboard is a bit off, then you could enforce this as a policy globally by just registering as a row filter on UC. And I don't know, you tested it?
I did.
Do we still get the push down for predicates and all of this into the tables, or do we hinder that by this application?
It still has to be, so because it does like the secure view, it's still running like the operation itself on a row to row to row to row basis. So it works. It's a little bit slower than just doing it directly against like if we think about the conditional like where clause. Conditional where clause is being essentially like applied once and then pushed down to the partitions. The other one is like essentially scanning because it's trying to say like, does this evaluate correctly? And it's using the event time of each row to go and check that as well. I didn't go super deep into like the query plan itself, but where we basically have like secure view, like within like the query plan, I didn't have a lot of information there that I could get into. So we could probably talk about that again, like in a different session too, where it's like, ways of doing things incorrectly with the tools that we have within Unity. But the interesting thing to like the point before is that like, if you always want to say we will only ever visibly show 7 days of data, unless you're part of a specific group, you could treat what's visible essentially as that policy as well. And that's a pretty powerful, capability.
We're staging data, but it's not active yet, right?
Yes.
So it gets prepared. Yep. But we need to close the book before this becomes sort of the source of truth we can and are allowed to rely on.
Yeah, and I think the other really interesting thing about that too is that because it's applied globally and you don't have to think about it at all, like if I want to go and basically create this composite view, I'm essentially only selecting whatever columns I want from that table and I'm not thinking about anything else. So I don't have to create that first view. This stuff will all just dynamically happen on its own, and it saves me a little bit of thought. I still have to think about taking the data and putting it into historic table itself, but that's fairly trivial when, my other table will always be accurate as well. So there are, there's problems that could be still, show up from all of this, but I
do find it though, one thing, at least from my perception, is, I don't want to say a general trend, right? But you have these, let's say, atomic tools at your disposal. And these keep growing and growing. In the open source, we also seen people use various abstractions like domain metadata or even the sort of commit metadata and stuff like this to build applications and experiences around these tables. And with Unity, sort of the tool set got a lot larger. But this is how I think you need to think about these sort of fundamental things you can do, because you can build solutions out of those that fulfill a business purpose.
Oh no, for sure. And I think the other thing too is that like if like I was just thinking more about like this use case too, and like in certain cases, if you don't have the ability to expose the rest of the table outside of like that 7 days to any other process that's actually running, then our ability to create a historic table would also break down as well. And so it's like there's certain things, right, where it's like, there's gotchas, and it's like, here, do this, and then it's like, Scott, you screwed it all up. We trusted you, right? And there's everything's a little bit more complicated, but like at a high level, all these things are possible as well. And the nice thing too is that like if we think about that union operation, being able to push down to the union operation as well, in certain cases, the actual union of our historic table, if I'm only looking back 24 hours or 2 days, etc., all of that stuff can basically just get ignored in the query plan as well. So there's certain operations that do not need to happen because of the intelligence of the entire Spark ecosystem. And yeah, so that's it. It's just a picture of my face saying that's neat. So we achieved hybrid dynamic views, and great. We're going to open up for questions in just a second. So I just wanted to say, like, this whole conversation came out of like a thread after Beyond Partitioning. So I have that up on like the right-hand side of the screen as well. So it was more of this, like, while liquid clustering gives us like all these benefits, and if you talk to anybody right now who's using Delta, it's like, oh, liquid clustering is the absolute shit. It also is very good for the things it's very good for. And in a lot of cases, you still have to go back and, do a kind of mixture model of, both, kind of classical hive-style with optimizations, and then, liquid clustering with optimizations as well. So, hybrid use cases are always kind of interesting. And now if there's questions from the audience, we will take those. So thank you.
Yeah, thanks, Scott. Very interesting, I believe. Kind of sharing some real world insights as well on what problems you have to solve if you get into the real world. Let's see if we have some questions out there. So there's one question I can field immediately. Sure. It's sort of tangential. Any update on Delta kernel for Python? I can talk to that. Doesn't really have much to do with sort of the specifics here, but we're actively working on integrating Delta kernel into the various ecosystem projects. The Delta Lake, Delta Rust integration is a current priority, and there's other projects where also the JVM kernel gets distributed. I think the best way to leverage kernel in Python would probably be via the Delta Lake library once it's integrated, which, I don't know, Q2, maybe, hopefully. But that was sort of tangential.
Yep. Yeah, there's another question. We can make the slides available as well.
Excellent.
Yeah, after the presentation, we just upload them, and then we could also talk more like so we wanted to go more into like the Unity catalog like options as well. Like we could talk more about like how to screw up things with row filters a little bit more. But like in general, like what was shown today can benefit a lot of like enterprises that have to toil with tables to be able to combine and create like a clean view of highly mutating data during a specific period of time. I think if there's any other kind of lessons to learn too, it's that like it's better to be able to retain, not indefinitely, the ability for a table to continue to mutate if you want to be able to actually have good query performance. And so those are like the biggest kind of pain points that people will probably ever run into, where it's like, oh, like we want a table that's going to be updating for a 3-year period. It's like, why? Like there's not a lot of cases where that's actually something that should ever happen. And so being able to really think about things as like you're kind of in a pre-planning phase, if you have the if the pleasure of doing that or the opportunity to do that, like asking why is always like a benefit at that point in time too, so that you can optimize as fast as possible.
And I think, the optimization, and that should be sort of a given in many senses, but there's always two sides that you can optimize for, right? You can optimize for the data engineer, making all your ingestion and all of this easy, or you can optimize for the business. I hope we lean on the business side of things, right? So the data engineers should solve interesting and complex problems.
Yes.
But ultimately, you're there to enable the business and not to keep your pipeline stable. I don't know, Scott, there is another question that may be interesting in this regard. So how can we do time travel historically? I have a history table. I want to do time travel so I can query without using STCs. Is that possible? I have to...
Well, I think, so if you want to going back in time for is it being loaded and then rewritten maybe in this case? So I think for some of this stuff, that historic, whatever the historic table is, from the example that we showed today, you can load essentially any kind of point from that time anywhere else. It's not necessarily a time travel, unless you want to kind of rewind to that specific point in time as well. So I think with that, I don't have a very good answer for it. For that.
But I think what you just said is very interesting, because whenever you have these log-like tables that, let's say, progress linearly, if we assume every update is prepare or fixing some issue on the data itself, right? So you probably don't want to kind of go back to an erroneous state of your data. But if you want an historical view at a specific point in time, it's as easy as saying, okay, don't show me data after this point in time for this specific scenario, right? There's other scenarios where stuff like this certainly doesn't work. But for the example we discussed, I think, yeah, you virtually get sort of a view of what the table looked like at that time just by filtering. Filtering by timestamp.
Yeah, I think so. There was an update to the question as well that just came back in. So it's am I able to rewind in time? This is the time in the past, and you can you can rewind to a specific point in that table time if you want to go and basically if I want to go where we had essentially talking about that file deletion interval of that 2 weeks on our historic table, that was giving us a buffer. That buffer can be as long or short as you need it to be able to enable time travel on your historic table. The big thing is if you are not making a lot of changes and it's essentially append only, for that historic table, you can store longer state so that you can go further back in time, because you're not really doing any deletes anyways. And so really that would be a fairly inexpensive operation. Really depends on what you want to do with it though. So if you're going back a month or 2 months and you don't have another table to fill in the blanks with, then you're essentially just kind of rewinding that pointer. And then you have to go fill in that, what's that current block of time with something else. If you have the ability to do a replay with that better data later, you can use that for any kind of triage to go and fix the table. And then you can re-optimize, you can do an optimize full on that table again. That just kind of goes back to the more complicated and probably more expensive type solution as well for that.
Yeah.
There's another question about liquid clustering supported in Azure Fabric. Liquid clustering is part of just regular Delta Lake open source. So I wouldn't see it not being supported in Azure. But I don't know if there would be selectively opting out of clustering. So it should be.
Yeah, to be honest, I don't know either. Whether or not you can enable that on Spark there, what knobs are exposed, or if they do their own optimization.
Yep.
Yeah.
All right, we're getting a 4-minute countdown right now. So I guess the further use case for what we were just talking about as well for like historic tables, like the example is like we have data from 2020 to 2025, do a full load on the March 25th. Now I want to do time travel back to a certain point in time. With that, like if you're doing like a full table load, you're going to have like a transaction for that table. And so like the version of the table, if you're doing like that full load, is going to be like V0 for a full load. So you wouldn't be able to use like classic delta time travel for that unless you are splitting up the load of data into individual transactions as well. And so it wouldn't be classic time travel. You could still go to a specific point in time with like a traditional kind of query. But if you're doing like, it really just all depends on like that use case. And if you want to do like a follow-up, I could answer more of those questions like in the Delta users Slack group as well, as I think it might need a little bit more context as well to talk about, the semantics of that as well. So.
Yeah. So there's another favorite question. Maybe reach out on Slack, but ultimately, I think Scott, neither you nor I know kind of the current support level in there.
No,
but yeah, if you ask on Slack, maybe we can see if we have some documentation somewhere.
Yep. I don't know. My gut says yes, but my gut's sometimes wrong, so I don't know. Let's see. Yeah. So I think we're just about at time right now. And so if you want to like ask follow-up questions, additional questions, kind of dive into kind of more, I don't know, just more kind of like, offline QA, like it might turn into another one of these webinars. And if nothing else, like you can talk with people in the community as well and understand more about like, the differences between, open source Delta and potentially like what is supported, within, the different, cloud vendor offerings as well. And that's pretty much it. So thank you, everybody.
Yeah. And I mean, you see the screen, you'll find Scott and me hanging out in these communities. So reach out.
Yes.
Happy if you join. Yeah. Thanks everyone for listening in.
Yes.
Hope it was helpful. Yeah. And